2, 1, T-minus 20 minutes and holding. This is a 10-minute build-in hold. There will be one additional 10-minute build-in hold, which comes at the T-minus 9-minute point. Everything has gone very smoothly in the countdown since we picked it up on Wednesday afternoon. It was a 93-hour count. We had one major build-in hold that occurred from midnight on Saturday until 10 minutes after 12 early this morning. And then we've been going down. We had another hold at the T-minus 3-hour point and then picked it up and are proceeding now towards launch. We were very concerned with the upper level winds here at the Kennedy Space Center starting last night. However, the winds have abated and we are in a go position at this time. The countdown at T-minus 20 minutes and holding. This is Shuttle Launch Control.
CPLE verified. EPD. BCD verified. GNC and flight controls. Verified. DPS. DPS is go. CCMA.
The computer transition to Ops 101 has just been made. Ops 101 is the computer program used for the ascent of the space shuttle into orbit. As we come out of the hold, the prime computer is dumped and compared with the onboard computer to verify that it has the proper configuration for launch. At this time, purge of the 3 fuel cells on board the orbiter is also underway. During this period, the flight crew will be configuring their computer for comparison tests. They have also been checking the horizontal situation displays. The crew is configuring their instruments for launch. At T-minus 16 minutes, the main propulsion subsystem cockpit switches will be configured and the helium tank isolation valves open for launch. The countdown clock at T-minus 19 minutes and counting. This is Shuttle Launch Control.
PLT, configure pass and BFS horizontal sit displays. Go ahead, COFC. Go ahead. Yeah, 628 is verified. 629 is okay. 630. We do not meet the criteria stipulated there. That will be corrected with the patch at T-minus 9 minutes. Copy. OTC, T-minus 20-minute dump compares in progress. Thank you. DPS, you ready for BFS uplink? Stand by. BPS is ready. Thank you.
And counting. Everything going very smoothly as we count now down to the T-minus 9-minute point where we will pause once again for a 10-minute build-in hold. The STS-6 flight is a flight having many firsts. It's the first launch of the Shuttle Orbiter Challenger. It's the first time we have used the lightweight external tank, the first time that we have used the lightweight solid rocket boosters. But on this mission of first, the 3 getaway specials also can claim some firsts. The one from the Park Seed Company of Greenwood, South Carolina, can lay claim to a number of them. The Getaway Special program allows companies, universities, and private individuals to send scientific experiments into space aboard the space shuttle for prices ranging from about $3,000 to $10,000. The Park Seed Company is taking advantage of the program to fly the first flower and vegetable seeds into space and also become the first company to use this program for a commercial or industrial application. Although the experiment occupies a small container, it has some broad scientific objectives. Learning to package seeds to survive the rigors of space travel and be used to provide food on manned orbiting space stations of the future is one such application. However, a much broader and vital objective will be allowing Park Seed Company scientists to learn more about the possibility of using space for storage of genetic strains which must be preserved for future generations, and the possibility of using space to produce desirable mutations in seeds. Another Getaway Special experiment is being flown by one of the largest newspapers of Japan. Japanese, who were the first to create artificial snowflakes on Earth, will become the first scientists to create artificial snow in space as well. The experiment, selected from 17,000 suggestions submitted by readers of Asahi Shimbun, one of the largest newspapers in Japan, with a readership of about 8 million. The experiment is expected to contribute to the knowledge of crystallography, especially the crystal growth of semiconductors and other materials from a vapor source. Semiconductors are the building blocks of most modern electric devices. Some scientists have theorized that the crystals may form of snow in a very symmetrical way, but others expect spherical crystals to form. The third Getaway Special is sponsored by the U.S. Air Force Academy. 6 projects were developed in an engineering design course at the Academy over the past 5 years. These experiments range from a demonstration of the feasibility of soldering beams in space to testing the effect of weightlessness on the development of microorganisms. 5 of the experiments fall in the metallurgy area with the study of the uniformity of metal alloys manufactured in 0G, the formation of metallic sponge, electroplating, and metal purification. The countdown continuing smoothly, the clock at T-minus 12 minutes, 30 seconds and counting. This is Shuttle Launch Control.
CPVD, OTC. CPVD. You can reduce your payload bay purge rates to launch. Didn't work.
This is Shuttle Launch Control at T-minus 10 minutes, 30 seconds and counting. The chase plane pilots have been ordered to start their engines, and other airports in the area have been informed that the radio frequency used by the chase planes will be active through launch and asked to keep that channel clear of other traffic. The NASA test conductor has asked safety and security to verify that all non-essential personnel have cleared the launch danger area and has been assured that the closeout crews have cleared the roadblocks. The purge of fuel cells used to generate electricity on board the orbiter has been completed. The booster test conductor has started the flow of gaseous nitrogen purge of the aft skirts of the solid rocket boosters. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid motors prior to ignition. The countdown clock just about 35 seconds away from the final 10-minute build-in hold in our count. The flight crew has closed the vent valve on the crew cabin, and cabin pressure has been verified. The comparison of the prime computer with the onboard computer has been completed, and that is satisfactory. All aero surfaces and actuators on the orbiter are presently in the proper configuration for the auxiliary power unit to start and hydraulic pressure to be applied. 5 seconds away from our hold. T-minus 9 minutes and holding. This is a 10-minute build-in hold. The STS-6 mission is a mission of many firsts. It's the first flight of the Space Shuttle Orbiter Challenger, the first flight of the lightweight external tank, which carries the liquid hydrogen and liquid oxygen for the main engines on the orbiter. Altogether, the weight savings are significant, increasing the cargo carrying capability. 20,000 pounds altogether has been saved compared with the last launch of the Columbia orbiter. This is also the first use of the higher thrust main engines on the orbiter. They will be operating at 104% rather than 100% of rated thrust. Another first scheduled for this flight will be the exiting of the crew compartment by mission specialists Dr. Story Musgrave and Donald Peterson to spend 3.5 hours moving about the cargo bay in the cold vacuum of space. At this time, Launch Director Al O'Hara speaking to the launch crew. Countdown. Looking for a liftoff on time of STS-6, the 6th flight of the Space Shuttle, and the first flight of the Orbiter Challenger at 1:30 p.m. Eastern Standard Time. The countdown clock about 5 seconds away from picking up the count. We are holding the clock at the T-minus 9 minute point while we check on the booster system. The NASA test director is in the process of checking with the booster test conductor to determine whether or not there is a problem. Okay, we have gotten to go to pick up the clock, and we will pick up in 10 seconds at the T-minus 9 minute point. Approximately 5 seconds. 3, 2, 1, T-minus 9 minutes and counting. The launch events are now being controlled by the ground launch sequencer from now up to the T-minus 25 seconds when they switch to the onboard redundant set launch sequencer. The ground launch sequencer is part of the processing system and operates by relaying commands to the orbiter's onboard computers, which then report back to the launch processing system when the commands have been executed. The primary job of the computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are proper. The launch and recovery director has ordered the chase planes to take off. Coming up on the 8 minute point in the countdown. T-minus 8 minutes and counting. Everything proceeding smoothly towards an on-time liftoff at 1:30. The liquid oxygen fill and drain valve in the external tank has been closed and topping of the tank completed. Liquid oxygen drain back has been started. This means that liquid oxygen is flowing through the main propulsion system and back to the large storage tank to cool the system down slowly to 270 degrees below zero, so they'll not be shocked by the torrent of super cold fluid. T-minus 7 minutes, 27 seconds and counting. At the T-minus 7 minute point, the crew access arm will retract and is in the process of retracting right now. This is the walkway used by the astronauts to get from the service structure to the orbiter. If an emergency should arise, that tower can be put back in position within 15 seconds. T-minus 7 minutes and counting. Like other things in the countdown today, we've been just slightly ahead of schedule as we go down towards a liftoff. T-minus 6 minutes, 30 seconds and counting. At the 6 minute point, the crew will perform the auxiliary power unit pre-start, which consists of positioning a number of switches and verifying that they are in the proper position, then throwing the 3 propellant isolation valve switches, which allow the hydrazine fuel to start flowing from the tanks toward the APUs. Coming up on the 6 minute point, T-minus 6 minutes and counting. The pilot, Karol Bobko, has been asked to perform the APU pre-start. T-minus 5 minutes, 49 seconds and counting. T-minus 5 minutes, 40 seconds and counting. The flight recorders are on. The flight recorders provide measurements of the shuttle system performance during the entire mission for playback after landing. T-minus 5 minutes, 25 seconds and counting. Everything going smoothly towards our liftoff. And we have a go for APU start. Coming up on the 5 minute point. T-minus 5 minutes and counting. I have go for APU start. APU start is in work. The APUs, or auxiliary power units, provide hydraulic power to move the aerosurfaces and main engines for steering. The astronauts have closed their visors. T-minus 4 minutes, 30 seconds and counting. The firing circuit for the solid rocket boosters ignition and range safety destruct devices has been armed by a ground launch sequencer command. This is accomplished by a motor-driven switch called an arm and safe device. The system is then inhibited to prevent premature ignition. T-minus 4 minutes, 5 seconds and counting. The main fuel valve heaters have been turned off in preparation for engine start. The main engines on the orbiter will actually be started at the T-minus 6.8 second point. It takes 3 seconds for them to reach 90% thrust, at which time the solid motor ignition sequence starts. T-minus 3 minutes, 40 seconds and counting. The elevon, speed brake, and rudders are now being moved through a pre-programmed pattern to ensure that they're capable of doing their jobs during flight. T-minus 3 minutes, 27 seconds and counting. The shuttle is now on internal power. However, the fuel cells are still receiving some fuels from ground support equipment for another minute. T-minus 3 minutes, 13 seconds and counting. The profile checks of the aerosurfaces is complete and verified, and the aerosurfaces are in launch position. Coming up on the 3-minute point, T-minus 3 minutes and counting, the engine gimbal or movement check of the main engines is underway.